example, we want to quickly see group, block, period of an element. How can you identify the block or the period to which an element belongs to? Now, to be able to answer that question, the first thing you should note is what we call the SPDF listening configuration. SPDF. Now, I want to know that S can carry maximum of 2, P can carry maximum of 6, D can carry 10, F can carry 14. That is the maximum. If I want to just know that S can carry 2, the rest you just need to be adding 4, 4. 2 plus 4 gives me 6, D 10, F 14. Now, why is this important? Take this question. An element X, Y, and Z. An element X, Y, and Z has the following electronic configuration: 1s2, 2s2, 2p4, 1s2, 2s2, 2p6, 3s1, 1s2, 2s2, 2p6, 3s2, 3p5. Let me also add an element Q. Just add that one. 1s2, 2x2. An element SYZQ has the following electronic configuration. Okay, I'm sorry, I want you to add this also. Let's give an scandium to be 21. There's something I want you to understand. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Okay. Now, I said an element has this following electronic configuration. Find the group, the period, the block of an element. Now, whenever you see a question in this form and you're asked for group and period, the first thing you're expected to do, remember I told you that anytime you want to get group and period, you must know their atomic number. The sum of these numbers here, the sum total, gives you the atomic number. So you just say 2 plus 2 gives you 4. 4 plus 4 gives me 8. That means this one is 8. If I want to do this, y, when I have this up, you are going to have 11. For z, if you add it up, you are going to this 2 plus 2, 4, 10, 12, 17. For your Q, you are going to have 4. Then scandium, you have 21. Now we'll just solve some so that you will be able to do the rest by yourself. Now, to get group and period, don't forget, whenever they ask you group and period, and the question is like this, they give you in this form of electronic configuration. Add up the number. Once you add up the number, then previously I've taught you that if you want to get group and period, always start with 2,8. Then you write it in 2,8 form. What I mean is that you will start with 2. After 2, you're supposed to write 8 because normally they got that 8 from the issue of octet structure. Later on in our next class, we'll explain that. But I just want to give you a simple tip on how to be able to answer questions related to group and period. You start with 2. After 2, you are supposed to write 8. But you only write 8 if it will not be more than the atomic number. This is what I mean. If I put 8 here now, 8 plus 2 will give me 10. And I'm looking for 8. So because I'm looking for 8, what will I add to 2 to get 8? That will just be 6. This one, it will be 2. I can write 8 now. I would have written 8 again, but I'm looking for 11. 8 plus 2 is 10. Here will just be 1. This one will be 2, 8, 7. This one will be 2, 2. Like that. So, the same thing you can just apply. Now, group is always the last number. So, this element now belongs to group 6. As simple as that. Group 6, period 2. That is how they get group. This one belongs to group 1, period 3. Group is always the last number. This one belongs to group 7, period 1, 2, 3, period 3. So with this, you can do the group is always the last number. Period is always the counting. So what this thing helps you to do is that this method will just help you to determine group and period easily. The next thing I want to go to is the issue of block. Whenever you are asked the block of an element, for example, if they ask you what is the block of X, You can easily get block based on where the electronic configuration stops. This thing stop at P, so it's P block. As simple as that. This one stop at S, so it's an S block element. This one stop at P also, is a P block. This one stop at S, is an S block. This one stop at D, is a D block. That's how to get block. Block simply means where that particular electronic configuration stop. Now the next thing I wanted to tell you about is how to get number of unpaired electrons. Whenever they ask you number of unpaired electrons, you need to know from the block the maximum it can carry. This is what I mean. Now this thing stop at P and it's having 4. And don't forget that we say P can carry a maximum of 6. So because it stop at 4, how many will you have to get to 6 is 2. So that is why this one, the number of unpaired electron is 2. For this one, it stop at S and the electron is carrying 1. And S can carry a maximum of 2, but it's having only 1. So how many will it remain to get to 2? Is 1. So that is why the number of unpaired electrons here will be 1. Somebody else says the number of unpaired electrons here is also 1 because P can carry 6 and something at 5. So the number of unpaired electrons is 1. For this place, S can carry 2 and that is the number. So the number of unpaired electrons here is 0 because S can carry 2 and it's there. Then for this particular one, D can carry 10 but it stop at 1. The number of unpaired electrons is 9. So with this, you'll be able to know how to determine this. I hope that is clear. So you can attempt the rest question to do that.